Hello class, welcome to lesson 1-8, which is all about logical reasoning and counterexamples. By the end of this lesson, you should be able to identify the hypothesis and conclusion in a conditional statement, and you should be able to use a counterexample to show that an assertion is false. Okay? I know that was a lot of big words, but we'll talk through them, I promise. So let's start with some of those large words. Conditional statement. A conditional statement can be written in the form if, and we're going to call it A, then B, okay? If it is nice out today, then I am going to go buy ice cream, okay? That is considered a conditional statement. If it is nice today, so if that happens, if it turns nice today, which is a little rainy today, so hopefully the sun will come out, but if that sun comes out, I am going to go buy ice cream, okay? So that is called a conditional statement. It is based on the condition that it gets nice out today. This form is also known as an if-then statement. You'll probably hear me refer to it as an if-then statement more than I'll refer to it as a conditional statement. But once in a while, I like to keep you on your toes, and I will call it a conditional statement. The book always wants to keep you on your toes, and they will generally always call it a conditional statement. All right, a hypothesis, though, a hypothesis, this should sound familiar from science, is the part of the statement following the word if. Okay? So in my last example, the hypothesis would be, there's the if, it is nice today. Okay? That is the hypothesis. The conclusion is the part of the statement following the word then. So my conclusion, then I will go get ice cream. That is my conclusion. Okay? Deductive reasoning is the process of using facts, rules, definitions, or properties to reach a valid conclusion. Okay? The process of using facts, rules, definitions, or properties. This is something that you're going to get into pretty in-depth in geometry next year. I'm just, introducing it so that way it's not such a foreign concept next year. Same with the word counterexample. A counterexample is a specific case in which the hypothesis is true and the conclusion is false. The hypothesis is true, but the conclusion is false, okay? We'll look at some of those today as well. So let's start with example 1. We want to identify the hypothesis and the conclusion in each statement. And if you're like me, sometimes you get a little lazy and you would prefer to just color code. So I'm going to underline my hypothesis in blue and my conclusion in green instead of rewriting these. So let's identify our hypothesis and our conclusion for our first statement. If it is the 4th of July, then we will see fireworks. Okay, so my hypothesis, remember, a hypothesis follows the word if. So it is the 4th of July is my hypothesis. My conclusion follows the word then. So my conclusion in this instance would be, we will see fireworks. All right? That is how you identify the hypothesis and the conclusion. Let's look at our next one. If 2x minus 10 equals 0, then x equals 5. Okay? So my hypothesis follows the word if. My conclusion follows the word then. It can be a little weird when they start introducing equations into your conditional statements, but it's the same concept. Whatever follows the word if is your hypothesis. Whatever follows the word then is your conclusion. Why don't you try to identify the hypothesis and conclusion of the statement? If it is above 75 degrees, then you can go swimming. Hopefully you said the hypothesis is it is above 75 degrees, and your conclusion was you can go swimming. If you have a question on that, please be sure to let me know. Let's take a look at our next example. We want to identify the hypothesis and conclusion in each statement. So again, I'm going to use my color coding technique. Identify the hypothesis and conclusion in each statement. Then write each statement in if-then form. Ooh, a little trickier this time because now we don't have the words if and then to signify what is the hypothesis and what is the conclusion. We have to determine that on our own. So let's go back to my example earlier where I said if it is nice out today, then I can go buy ice cream. If it is nice out today, so that's kind of like that's the condition. That's what affects whether or not I go to buy ice cream. That's what we want to look for in this first example. We want to go and look to see what is going to be the determining factor of if something else happens. Okay, so Julie gets chocolate chip ice cream when she is at the ice cream parlor. Okay, Julie gets chocolate chip ice cream when she is at the ice cream parlor. So what has to be true in order for the other part to be true? The two parts we have is Julie gets chocolate chip ice cream when she is at the ice cream parlor. So those are our two parts. We need to determine which one has to happen in order for the other one. So is our hypothesis going to be that gets chocolate chip ice cream? Let's try it. If Julie gets chocolate chip ice cream, then she is at the ice cream parlor. It kind of works. Let's try it the other way. If Julie is at the ice cream parlor, then she gets chocolate chip ice cream. I think that one might make a bit more sense because that would signify what she gets there. So I'm going to say that that is my hypothesis. My conclusion is that she's going to get chocolate chip ice cream. So now let's rewrite this statement in if-then form. So we'd say, if, because we always start with an if, Julie is at the ice cream parlor, then she will get chocolate chip ice cream. And I am done. Now let's look at the next one. Students tend to like rewriting these ones in if-then form. They say it's easier. Hopefully that holds true for you too by the end of this example. We want to identify the hypothesis and the conclusion for each statement. When you have the equations, the part that is always going to be your hypothesis is the equation, and the part that is always your conclusion is going to be the part that tells you what your variable equals. Okay? That's how it always works. It's pretty great. So let's rewrite that. If 3y plus 4 equals 25, then y equals 7. Done. Okay, so hopefully you see the awesomeness in that, and the fact that they're easy to rewrite in if-then form. Alright, why don't you take a minute and try to identify the hypothesis and conclusion of the statement, then write the statement in if-then form. We go bowling on Fridays. Okay, so hopefully for this one, you said the hypothesis is we go bowling, or we are bowling. The conclusion is it is Friday. So our statement is, if we are bowling, then it is Friday. They skipped the word then, but I think you get the point. Example 3, we have determine a valid conclusion that follows from the statement below for each condition. If a valid conclusion does not follow, write no valid conclusion and explain why. Okay, so those directions might be a little bit confusing, but we'll work through it together, okay? So first, let's read the problem that they want us to. If one number is odd and another is even, then their product must be even. If one number is odd and another is even, then their product must be even. Okay, so we want to determine a valid conclusion that follows for each statement below for each condition. If a valid conclusion does not follow, so if A and B don't make sense, we're going to say no valid conclusion and explain why. Alright? So let's look at letter A. The numbers are 5 and 8. Okay, so does that fit our hypothesis? Our hypothesis, one number is odd and another is even. Okay, so 5 we have odd, 8 we have even. Okay, so it meets the criteria for our hypothesis. then their product must be even. Okay, so we have odd and even. And then if we do product, that's multiplication. 5 times 8 equals 40. So is that a valid conclusion? Then that the products are going to be even? Yes. So you'd say, here, I'll rewrite it over here. You'd say 5 is odd, 8 is even. So you'd say the hypothesis is true. This is what I want to see on your paper. I know I verbally said that, but I want to demonstrate what I want to see on your paper. So you need to show me that the hypothesis is true. And then you'd say the product is 40. So the conclusion is also true. Okay, that's what you would write for your first answer. Now let's take a look at the next one. If one number is odd and another is even, then their product must also be even. So if we look at letter B, the product is 24. Okay, so it's jumping to our conclusion. It's telling us that our product is 24. Is 24 an even number? So 24 is even. So our conclusion is true. Okay, but now we need to find what makes our hypothesis true as well. So what are some numbers that multiply to 24? See, we have 8 times 3 would be one example, and one is odd, one is even, so that checks out. Let's see, what else multiplies to 24? We could do 6 times 4. Uh-oh, both of those are even though. Okay, so since both of those are even, we would say no valid conclusion because 6 times 4 equals 24, and 6 and 4 are even. Okay, so that's how you justify your answer on that one. Try this one on your own, see how you do. Hopefully for this first one you said the number is divisible by 10. If not, be sure to ask for some help and try this next one on your own. Hopefully on this example you said that there was no valid conclusion. Again, if you need help with any of these, let me know or a friend know. And let's look at example 4. It's our last example together today. So find a counterexample for each conditional statement. Okay, counterexample, basically I want you to prove me wrong. I want you to prove this example wrong. So we have if A plus B is greater than C, then B is greater than C. So we want to figure out what numbers we can plug in to make this true, and then also make this, well, we don't want to make that true, sorry, we want to prove that that's false. That is not always going to be the case, because that's what it means by counterexample, okay? So if A plus B is greater than C, let's come up with some numbers there. So if I say, let's go with 6 plus 2 is greater than 5. Okay, so 6 plus 2 is greater than 5. Then that means 2, because letter B represents our 2, 2 is greater than 5. Is that true? No, that is not true. So you can draw a line through your greater than symbol, and you'd say that would be an example of this. That would be a counterexample. Sorry, not an example. That would be a counterexample. That is you proving that problem wrong. I know you guys tend to like proving people wrong, so hopefully you enjoy that as well. Try looking at this next one. If the leaves on a tree are brown, then it is fall. Is that the only time that leaves on a tree are brown? Is during fall? I don't think so. You might be yelling at your screen right now or thinking in your head, like, come on, Miss Johnson, there's an obvious answer. But it's not always obvious. It's okay if answers aren't obvious to you because this is a learning process. Okay, this is all about you guys learning how to think and stuff. So it's okay if you don't know these right away or if these are confusing. So if the leaves on a tree are brown, then it is fall. Well, if you think about it, the tree could be dead. Because if a tree is dead, then it cannot produce everything that is needed in order to make colorful leaves. Okay? It is not getting the nutrients it needs. So that would be another example of when the leaves on a tree could be brown. Your turn to try to find a counterexample for this statement. If x is less than or equal to 1, then x times y is less than or equal to 1. Show me which one is a counterexample. Hopefully you said or discovered that x equals 1/3, y equals 9. If you had any issues with that, please let me know. I'd be more than happy to help you. I hope you guys have a fantastic night. See you tomorrow.